Morning everyone. Today is Sunday and it is the day before the GP A-level paper, and on Tuesday will be H2 Math paper 1. So this should be the last pure math I'll go through. Hwa Chong Prelim 2022 paper 2, the pure math, and I'll also go through the stats. And I'll go back to ACJC 2021 and Diamond High 2022 to do the stats papers as well and get those up before Friday when there's the paper 2 with the stats. So all the best to everyone. Now, I personally think that this paper is a bit easier than paper 1. The pure math is very A-level-ish, and the stats is a bit more challenging, but nevertheless, it's a pretty fair paper. So let's have a look. Okay, first question, 3 transformations to get a quadratic curve. So this is actually quite simple. So let's look at the final equation of the curve. Y equals negative x squared plus 3x minus 4. I'm going to complete the square, and this is going to give me negative x minus 3 over 2 squared. And then you will get the minus 9 over 4, but you're missing another 7 over 4. Okay? So if you write this as minus y equals to x minus 3 over 2 squared plus 7 over 4, it should become obvious what needs to be done. So the transformations, remember, it is to the curve y equals to x squared. Don't go the other way around. Okay, so what would I do? Well, I would do the translation first and then do the reflection. So translate 3 over 2 units in the positive y direction. X direction, sorry. Okay, and then also translate 7 over 4 units in the positive y direction. When you're doing translations, it doesn't matter which one you do first. Then the last one is we're going to do the reflection. So when you replace y by negative y, that is a reflection in the x-axis. So that will be your 3 transformations. I should indicate that this is question 1. Okay, so that was very simple. Question 2 is parametric. So sketch the curve for the domain of the t is 0 to pi over 2, so take note of that. So this is x and this is y. So you can of course just use your GC to sketch this, and if you do, you'll get a curve that looks something like that. Oops. You'll get a curve that is decreasing and has an asymptote. Okay, so this is the coordinates of x-intercept. This is actually going to be 0 and 1. This is the origin. This is the curve C, and the asymptote here is y equals to 0, the x-axis. Okay, so that's actually pretty much it. Maybe I should make the curve a bit clearer that it's approaching the asymptote. Yeah, that's about it for this curve. For the second part is find the area. Okay, so the lines, the y-axis, y equals to half and y equals to 1 over root 2. So half is here, and 1 over root 2 will be somewhere over here. So we want to find this area. And of course, we are going to integrate with respect to the y-axis. So we'll do the integral. Let me write area. This is the integral from half to 1 over root 2 of x dy. But we are given parametric, so we need to change dy to dt. So if I change this, I need to change the limits of integration as well. The derivative of cosine is negative sine, so I will get negative sine square t tangent t dt. I need to change the limits of integration. Now, when y is half cosine t, or rather t is, when cosine t is half, your t will be pi over 3, right? And then when it's 1 over root 2, it will be pi over 4. Then we're going to use a bit of properties. So I'm going to change this to, okay, I'm going to do this in, combine two steps into one. I'm going to change the limits of integration because pi over 3 is greater than pi over 4. So bring this to the top and take away the negative. At the same time, sine squared is 1 minus cosine squared. So I'll get tangent t minus sine t cosine t. So that is the integral from pi over 4 to pi over 3. Tangent t minus half sine 2t dt. And then you can proceed to integrate. So this is ln mod secant t minus plus actually quarter cosine 2t. And this goes from pi over 4 to pi over 3. Okay, so you have ln 2 plus, or ln 2 minus 1 over 8 minus ln root 2. The pi over cosine pi over 2 is 0, but ln root 2 is half ln 2, so I can factor out the half, or 1 over 8 actually. I'll factor out the 1 over 8 and write 4 ln 2 minus 1. Yeah, that will be the area. Complex number. Okay. So we have z equals to 2 cosine beta plus I sine beta, which we will realize is actually 2e I beta. Okay. Show that z over 4 minus z squared is k cosecant beta I, so it's an imaginary number. So z over 4 minus z squared, well, this is 2e I beta. 4 minus 4e I, 2i beta actually. Okay, and of course you can reduce this. So let me write this as that, 2 minus 2. Okay, and here is what I'm going to do. I'm going to actually factor out the half first. And what's going to happen is I'm going to multiply the top and bottom by e negative I beta. Okay, so I'll get 1 minus e2 I beta times e negative I beta. So this is like a half angle kind of trick. If you do that, you'll get 1 at the top. 1 over, this is e negative I beta minus e I beta. So I'll write this as negative here, and I'll put the e I beta first, minus e negative I beta. Okay, now here is the trick. Recall that you can see that e I beta minus e negative I beta, this is actually the difference of a complex number and its conjugate, which is always 2 times the real part. Or rather 2i times the, 2i times the imaginary part. So I'll get 1 over 4i sine beta. So that's the cosecant beta settled. But what is negative 1 over 4i? If you multiply the top and bottom by I, you will get negative 1, so it becomes positive. So it becomes quarter cosecant beta. Quarter I cosecant beta. Yeah. Hence k is 1 over 4. So, given that the complex number is this, so w equals to negative root 3 plus I, and we can write this in a complex, we can write this as the polar form. So the modulus will be 2, right? Because 3 square plus 1 square. And then if you draw your Argand diagram, you will get this is argument ei 5 pi over 6. Okay, so find z over 4 minus z square W conjugate to the power of n is real. Okay, so that is to say, so the argument z over 4 minus z squared plus argument of n times argument of w. So let me write this as n times the argument of w conjugate is a multiple of pi, right? Because all the real numbers have argument 0 and pi. So we have argument of z over 4 minus z squared is actually quarter cosecant beta is just a positive constant. So the argument of that is just pi over 2. So pi over 2 and w conjugate is 5 pi over negative 5 pi over 6. So pi over 2 minus 5n pi over 6. Combine this together, you will get pi over 6, 3 minus 5n is a multiple of pi. So 3 minus 5n. So 6 divides 3 minus 5n. So you can start writing down the values of n. You will realize that the smallest value will be 3. And then if you want to get more, because 5 and 6 are co-prime, you need to add 6 every time. So you'll get 3, 9, 15 as the 3 smallest values of the integer, so that you get the real number. Okay. Question 4. Find the following sum. R equals to 1k, negative half r plus 1 plus ln r plus 1. Okay, we're going to separate this into two sums. So let's make the power of this negative 1 so we can apply sum of GP. So this is going to be quarter the sum of, let me just bracket it off so that's a bit more clear. R equals to 1k, negative half, r minus 1. Then sum r equals to 1 to k ln of r plus 1. So what is the sum of this? So apply the sum of GP, you get 1 minus negative half power n divided by 1 minus negative half, so you times 2/3. So 1 over 4 times 2/3 is 1 over 6. So you get 1 minus negative half n plus, now this is ln 2 plus ln 3, which is 2 times 3. 2 times 3 times, actually let me do this. Ln 2 times 3 times dot 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 times, you'll realize that this goes up to k plus 1. So that it multiplies every number up to, from k plus 1 all the way down to 2. And you can multiply by 1 for good measure, but it will be the same, right? So this is k plus 1 factorial. Therefore, it's just 1 over 6, 1 minus negative half power n plus ln k plus 1 factorial. Okay. Oh, and I should write, this is k, not n, sorry. Hence, determine whether the sum exists, the sum to infinity. Well, it does not exist, right? I think it's quite clear. Does not exist because k tends to infinity, then ln k plus 1 factorial also tends to infinity. Okay. Part B. First term of the arithmetic progression is positive. The sum of the first 6 terms is 4.5. The product of the first 4 terms is 0. Okay, so let A be the first term and D the common difference. Okay, so we have, let me make this a bit clearer. So we have the sum of the first four terms, which is half times the first term plus last term. Oh no, sorry, it's 4 over 2, 6 over 2. So it's 3 times the first term plus last term, which is a plus 5d. This is 4.5. Okay, and we also have a plus d, a plus 2d, a plus 3d is 0. Okay, so that means that one of these is going to be equals to 0. And how can we find out which one is it going to be? Well, we can make a realization that it has to be the last one, because a has to be greater than 0. So let me see what I wrote here. We need a to be greater than, okay, so this tells us that a needs to be greater than negative 5 over 2d because of this one. Because if a is not greater than negative 5 over 2d, then you're going to get a negative number. So yeah, so clearly, if you want it to be 0, if you want the a to be greater than 0, you need a plus 3d equals 0. Okay, and therefore, we can sub this back in, so we get negative 3d, or rather we can sub this in to get actually negative 3d is just a equals to 9 over 2, and the common difference is negative 3 over 2. Okay, and finally, 13th term equals to 9 over 2 plus 12 minus 3 over 2. And this is negative 27 over 2. Yeah. Question 5, vectors. Okay, vector geometry. I had a look at this question. It looks like it's quite long, but actually it's not a difficult question if you can understand what's happening. Okay. So, what is the value of S? So D is above the origin, and you can read the question. It says that the height of the trapezoidal prism OABCDEFG is a height of 12 units. So actually that just tells you that S is 12. The line DM is parallel to the vector 11t, and plane ABFE is equation 6x is 36 plus z. The line DM does not intersect with the plane ABFE, so that means that the line is parallel to the plane, meaning that since we are given we have the Cartesian equation, meaning we have the normal vector to the plane. So the normal vector has to be perpendicular to 11t. So we write 11t dot, the normal vector will be 6, 0, minus 1. And we need this to be 6 minus t equals to 0 because they are perpendicular. So therefore t is 6. Okay. Show that the equation of DGM is given by this. Okay, so we need to show that DGM and ABFE are actually parallel planes, and then we can just use the position vector of D to help us out. So if you read the question, we are given that DG is parallel to AB, and we are also given that DM is parallel to AE. You can read the question and it will actually tell you all this. Okay? So therefore, you can specify a plane using like two vectors, like you know how two non-parallel vectors always specify a plane? Yeah, you can go on to explain that, and you will arrive at the fact that the plane DGM is parallel to ABFE. So they must have the same normal vector. So therefore the vector will be r dot 60 negative 1 equals to, pick the point D, negative 2012.601, and you will get oh wait, this is a minus 1, I think. Yeah, this will give you negative 24. So k equals to negative 24. Okay, find the acute angle between DGM and DEFG. I'm actually not sure how they gave 3 marks for this. So you realize that DEFG is parallel to the XY plane. Meaning that the normal vector will be 0, 0, 1, right? So therefore the angle, so when you're comparing plane and plane or line and line is cosine, if you're comparing line and plane is sine. So basically the same type of object will be cosine, different object will be sine. So this is cosine inverse of, so you dot the two normal vectors. So I'll take the normal vector to DGM is 601, right? So 60 minus 1 dot 001, then divide by the mod of both vectors. Which just turns out to really just be turns out to be cosine inverse of 5 over 30, root 37, which is 80.5 degrees. Okay, 1 dp. Part 5, find the coordinates of M and the exact shortest distance from M to the plane ABFE. Okay, so M obviously lies on the vector dm, but the vector dm is 1, 1t. So I have dm as a line. R equals to, pick the fixed point of D, which is minus 2, 0, 12. Then plus lambda, the direction vector, 1, 1, 6. Okay, so lambda is a real number. So lambda equals 2 because you see, once again, read the question. The pentahedron DEFGMN has a height of 12 units, which is 6 times 2. Okay, so therefore M is, the coordinates are 0, 2, and 24. Okay, the shortest distance from M to plane ABFE, you can find the you can use the shortest distance from point to line formula, but an alternative, which is I think it's the same thing essentially if you go and work it out, but you can find the distance between two planes, DGM and ABFE. I think that's easier in this case. So distance between two planes okay, so you take the, this is the, they have the same normal vector, which is 60 minus 1. The DGM is minus 24, and ABFE, well, we need to work it out. So we'll do 60 minus 1 dot, pick a point. So pick literally any point on ABFE. Now A is just 6 to the east of O, so it's 600. Okay, and this gives me 36. Okay, so therefore you will get mod you take the difference, so you get minus 24 minus 36. Okay, then you divide by the mod of the common normal vector, which is 601 minus 1. Okay, so that you get, it says exact shortest distance, you will get 60 over root 37. And you can leave it at that. Another plane pi has equation x equals to c. The three planes O, A, E, D, E, F, N, and pi intersect at E. Okay, so if you look at the diagram, you will actually realize that the x coordinate of intersection must just be E. Okay, so C will actually be that exact point also. Okay, so if you do a little bit of work, you can just find the position vector of E. Not that hard. It's just to 10 to the east of D, which we already know what it is. So OE equals to D was what? Minus 2 plus 10. So 8, 0, 12. Okay? So therefore C is 8. That's it. I don't know why they give so many marks for vectors, Hua Chong. It's a bit surprising. But yeah, that's that. Okay. Now we go on to the stats. Okay, Toddler Roy, the ship sorter. So stats, I feel like one of the big things about H2 stats versus H1 is that H2 problem statements tend to be a bit tougher to comprehend because they make it a bit more difficult essentially. And H2 has discrete random variables and circular permutations, which H1 doesn't have. I think those are the main differences. Okay, so 6A. So Roy picks one of the two blocks and places it in the shape sorter. 0.9 probability that you will correctly place the chosen block. If it is a correct one, then probability it is square is 0.4. The shape sorter will not light up. So there are two possibilities if you read the question. The box only lights up when the triangle block is correctly placed in the triangle hole. So either you pick the square and then it doesn't matter which hole you put it in, or you pick the triangle and it doesn't go into the correct hole. But of course, calculating those two cases is a bit harder. You might realize that we can actually calculate the one case that does work and then use complement. If correct block, probability, triangle, because there's only square and triangle, it's just 1 minus 0.4, sorry. Oops. So that is saying that 0.6 is the probability that the block was a triangle, given that a correct block was placed into the correct hole. Okay, so required probability is the complement method. So you take 1 minus the probability that you do actually use a triangle. So 0.9 times 0.6. So this is 0.46 because this is 0.54. Okay, so that will be it. For part B, 4 more identical triangles and R more identical square blocks. Okay, there's only 3 marks, but I feel like the working is a bit longer for this one. Okay, so you have 5 triangles and R plus 1 squares, just to be clear. Okay, now Joy chooses 5 blocks for replacement. The probability that chooses exactly 2 square blocks is twice the probability choosing exactly 4 square blocks. Okay, so what is the... So choosing 5 blocks without replacement, how can you do that? Well, you have R plus 6 total items, so the thing is just R plus 6 choose 5 at the bottom. And then what about the top? So 2 square blocks. To choose 2 square blocks, you choose 2 squares and 3 triangles, basically. And you can do this in how many ways? You can do this in 5 factorial, 3 factorial, 2 factorial ways. And then you do R plus 1 r, then you do 5 times 4 times 3. Okay. Okay. And then this is equals to, this is twice the probability, so you do 2 times. What's the probability of choosing exactly 4 square blocks? You do 5 factorial divided by 4 factorial. Then you do r plus 1 times r minus 1 times r minus 2, which I think some of you will realize is actually never mind. This is r plus 1, r minus 1, r minus 2. Okay. And then of course you need to choose one of the triangles. Which is, you can choose 5 of them. Okay. And then again, this is r plus 6, choose 5. So 5 factorial divided by 3 factorial, 2 factorial, this is 10. And this 5 times 4 times 3 is 60. So you get 600 r plus 1 equals to, then this is 5 times 2, so you get 1050. Okay. R plus 1, r minus 1, r minus 2. Okay. So now, oh wait, I forgot the r. There's an r at the top, I think. Yeah, sorry, so sorry. Forgot the r. R plus 1. Okay. So clearly, r is greater than 0, so we can do a bit of cancelling. So you will get 12 is greater than, or no, 12 is equals to r minus 1, r minus 2. So therefore, r squared minus 3r minus 10 equals to 0. Then you can solve this to find the values of r. You will get r plus 2r minus 5 equals to 0. So r equals to negative 2, which is rejected obviously, or r equals to 5. So yeah, that will be the answer. There's quite a bit of work for this question, but I think it's still manageable. Okay, question 7 seems like hypo testing. So company has a machine makes chocolate bars, produce chocolate bars with an average fat content of 30 grams. The machine is still 30 grams or not. So select a sample of 40 grams, 40 chocolate bars. Is it necessary to assume that the fat content of chocolate bars is normally distributed? Okay, this is a standard question. The answer is no, because central limit theorem applies. And why does central limit theorem apply? To the sample, since n equals to 40 is large. Okay, of course, write it out in words and give the context when you're actually doing the question. But I think we can all kind of understand that. After some years, it broke down. They reverted to traditional mode, and they have higher average fat content. That's what the manager suspects. At a 5% significance level. Okay, calculate unbiased estimates of the population mean and variance. Okay, I don't think I really need to show you how to do this. The sample mean, okay, I guess I will show you, because we have x minus 30.5 square here, and we need to compare the same thing. So what we can do is we can write x minus 30.5. The sample size is actually 40. So if you do 30.5 times 40, you will get 1220 exactly. So this is actually 0. Yeah. So therefore, sample mean equals to 1220 divided by 40 equals to 30.5. Unbiased estimate of population variance is, okay, so this is the 1 over n minus 1. So 1 over 39. So you take the square of the values, sum of the square values, which is 50, minus the square of the mean. Then you divide by the sample size. So this is just 50 over 39 lah. Okay? Yeah. Think that's no problem. The sample mean fat content of the handmade chocolate bars is denoted by X bar. State the null and alternate hypotheses. Okay, so the manager suspects that the fat content is increased, is higher, right? So therefore, the hypothesis will be test H0. Okay, mu. This is the population mean. So mu is equals to 30 against H1. Mu is greater than 30. But what is mu? Where mu is the population mean, right? In the chocolate bar. X bar is the sample mean, so don't confuse it. Okay? Calculate the range of values of X bar for which the null hypothesis would be rejected at 5% level of significance. So, honestly, I just use my GC for this. But I think I need to show the working, right? I don't like showing working for hypo testing, but let me get it out anyway. So we define X bar as following the normal distribution with mean, oh yeah, I should say under H naught. Under H naught by CLT, X bar follows the normal distribution. Under H naught is you assume that the mean currently is true, 30, and you take the variance. The unbiased estimate of population variance was 50 over 39. So you do 50 over 39, then you divide by 40, because that's the population, that's the sample size. So 5 over 156. Okay, approximately. Then of course you standardize. Z follows the Z equals to X bar minus 30 divided by the square root of 5 over 156, which is the normal distribution. So you need the value of test statistic to be greater than, you're conducting a one-tail test, so at 5% significance level, which means that you need Z greater than 1.6449, right? Yeah. So then you can find the set of values from here. And you will get X bar. So therefore, X bar has to be greater than 30.3. Okay? So because our sample mean is 30.5, okay, so therefore, which is greater than 30.3, so reject H naught in this case. And then you write the standard conclusion. There is sufficient evidence. There is sufficient evidence at 5% sig level that the mean fat in a chocolate bar is more than 30 grams. Okay? Yeah. The manager now knows the population variance of the fat content in handmade chocolate bars. The population variance is smaller than the unbiased estimate. Will there be a change in the manager conclusion? Okay? You don't need to do a second test to actually find out the answer, because we already rejected it with this variance. What happens when the variance is smaller? If you draw a normal distribution curve, so it looks like this, right? What happens if the variance is smaller? It means that the values are closer to the mean, right? If the variance is very small, you have a peak like that. Okay? So actually, it means that the p-value, the critical value, will be closer to the mean. Smaller variance implies that the critical value is closer to the mean. Okay, so that means that the p-value at the same level will be even lower. At same value of z statistic, p-value is even less. Therefore, there is no change in the conclusion. So it's just a bit about understanding how the normal distribution works out, basically. Okay, question 8, B and C. A school canteen committee of this, okay, there's a married couple, okay. Okay, so how do we do this? Oh, I think I just wrote this in one line without explaining how to get the answer. Sorry. Let's have a look. The couple cannot serve on the committee together, so there's two ways you can get the parents. One way is to completely exclude the couple and just choose 4 parents from there. So therefore, that will be 8 choose 4, right? The other way is you take one of the 2 parents from the married couple, but you don't consider the other one. So you take plus 2 times, then you need to choose the other 3, right? There are still 8 other parents which are not committed to one another, so you just do 8 choose 3. Then there are no more restrictions, so the rest is just you choose 2 out of 5 student leaders, so 5 choose 2. Then you choose 4 teachers from 8, so 8 choose 4. Yeah, that will be the entire calculation already. And this turns out to be 127,400. Okay. All members have to stand in a row to take a group photo with the vice principal. Find the number of arrangements so that the vice principal is the center. Both ends of the row are occupied by student leaders. No 2 parents stand next to each other. Okay. So if I put the student leaders, so I will use L for leader, V for the vice principal, and L for the leader. So you have, so for example, I can put one possibility is parent, teacher, parent, teacher, parent, teacher, parent, teacher, right? But there's actually more than one possibility. For each one, I can actually put, I can put teacher, parent, or the parents just need to be separated, right? So I put parent, teacher, teacher, parent. So there's 3 possibilities. So then I do this times 2. But the leaders, you can arrange them. You can also flip them around. So you get 2. And then the vice principal doesn't matter because it's in the center always. Okay, so you take, there's 3 ways that you can arrange them on each side. So you do 3 times 3. And don't forget that you can still rearrange all the parents and teachers. So you do 4 factorial times 4 factorial. Okay, and this is oh wait, this is 10,368. Okay, they are seated at a round table with 11 chairs. Find the probability that the parents are seated together and the teachers are separated. Okay, well, how many ways are there without restrictions? Remember, the people are actually all considered different. They have different names and different identities even though they are the same sort of category class of people. So you can arrange circular permutation. The way without restrictions is 11 minus 1 factorial, 10 factorial. By the way, I don't know if your tutors have told you this. If you consider objects to be identical, then you cannot account for originium in a circle. It is very difficult to count P and C in a circle if you can consider identical objects. It's not in H2 Math syllabus. Okay, so now we consider the ways. So the parents are seated together and the teachers are separated. So what does that actually mean? So that means that we need to imagine a line. So let's say that I have the parents and the teachers have to be separated. you realize that there are 3 other types of people other than the teachers, which are the 2 student leaders and the vice principal. So the only way is to either have the student leader stand here and the vice principal there, or these are the 2 ways. Okay? So to get the parents to be all together, it will be 4 factorial. Then the teachers can also stand in 4 factorial ways. Then how many ways can you arrange these two? The 2 leaders and the vice principal. Well, the leaders can always swap positions, so that means it's 2 times 3. Actually, this 2 is 2 factorial, I should say. Yeah. And if you work it out, you should get 1 over 1050. Yeah. Okay. Okay, this one. Abel has a white bag of marbles and 1 black bag of cards, and you create a game. Okay. In each round, Abel chooses a marble. If it's a red marble, the score is 4. If a non-red marble is chosen, Abel will choose a card randomly from the black bag with twice the number shown on the card. So 0, 1, and 2. So actually the only possible scores are 0, 2, and 4. You will realize that. Okay? Find the probability that Abel will get a score of 4 in a round. Okay, so there's 2 cases. One case is you draw the red marble, and then you don't need to worry about anything else already, right? So you have 2. How many marbles are there in total? 3x plus 1. Because it's 2x minus 1 plus x plus 2. Then you plus the probability that you don't draw a red marble, and that is 3x minus 1 over 3x plus 1. What's the probability that you draw the card with 2? Because that will give you the score of 4, right? 2 times 2. So that is just 1 over 3 times of 3x minus 1 divided by 3x plus 1. Okay? And then simplify your answer, because clearly this can be simplified. And you will get 1/3. So this is 6, so you get 3x plus 5 divided by 3x plus 1. Okay? Find the probability distribution of Abel's score. Okay, so this one is just tabulate the values. So this is x and the probability that x equals to x, where x is the score. Actually, no, I should use s, because x is already the number of marbles. Okay, so let s be the score. So the probability distribution, so we have s, and ps equals to s. Okay, so the only possible scores are 0, 2, and 4. We already know that the probability here is 1 over 3, 3x minus 1 times 3x over 3x plus 1. Okay. What about the other 2? You'll realize that the only thing that differs is the card number, because it doesn't matter what marble they drew. As long as it's not red, they will immediately get 0 or 2 or 4. But for you to even get a 0 or 2, you need to first not draw the red marble. So therefore, you need to first get 3x minus 1 over 3x plus 1. And you still need to draw the correct card, which has a probability 1 and 3. Oh wait, this is 3x plus 5. Sorry, I just realized. So this is 1 over 3, 3x minus 1, divided by 3x plus 1. And actually this number 2 is exactly the same. 1/3 3x minus 1, 3x plus 1. Okay. Yeah. State the mode of Abel's score. So that is just the most common value. And I think it's quite obvious that the modal score will be 4. Show that the variance, okay, this one is kind of annoying. It's just asking you to show that you know what is expectation and variance. So the expected value of S. So what's the expected value of S? So you take, we can ignore the 0. We do 2/3 So 2/3 3x minus 1 plus 4/3 of 3x plus 5 divide by 3x plus 1. And this gives us 6x plus 4 then, oh wait no, 9x plus 9. Who is messaging me? Okay, so this is 2/3 6x plus 10. So yes, it's 9x plus 9 times 2/3, which is 6x plus 6. So you actually get 6 times x plus 1 divided by 3x plus 1. Okay, we find the expectation of s squared now. And same thing, we take the 2 but we square that, so we get 4 over 3, 3x minus 1. Then we do this with 16, because 16 is 4 square. 3x plus 5, and then 3x plus 1. And what does this give us? So this is 12x plus 20, so 15x plus 19, unspotted. 15x plus 19 over 3x plus 1. Oh, and then we multiply in. So we get 60x plus 76 over 3 times 3x plus 1. Okay? And then from here, I think you can figure out already, because the question is kind of leading you to it. The variance of S is the expectation of S squared minus the square of the expectation of S. Wait, yeah, which is 60x plus 76 divided by 3 times 3x minus 1 plus 1 minus 6x plus 1, right? So 36x plus 1 square divided by the 3x plus 1 square. Yep, there you go. A bit annoying, but doable. Part 5. X is 3. A bell plays 100 rounds of the game. The probability that the average score is not less than 2.5. Okay, so we have, so when x equals to 3, what is ES and VAR-S? You will get expectation of the score is, I think, 12 over 5, and the variance equals to 208 over 75. I'm not going to show you how to calculate this. I just use my GC. Okay. Now I have 100 rounds of the game, so average score is not less than 2.5. Obviously, it'll be very difficult if I have to count each individual one. Luckily, 100 is a large sample, right? So I can use central limit theorem. So S bar is normal, 12 over 5. And then you take 208 over 75 divided by the sample size of 100. So you will actually get 52 over 1875 by CLT approximately. Okay, since n equals 100 is large. Okay, so that's cool. And you will get, so we just need to calculate probability. S bar is greater than or equals to 2.5, which you will get 0.274. Okay, yeah. Okay. Oh, this one. Okay, give me a short break. Okay, so for 10A, this is the answer given by Hua Chong. I just thought I'd talk a little bit about it because the question seems to be a bit, I feel like the way that they phrase it is a bit A bit unclear, but nevertheless. So if you want to draw the regression line of y on x, remember that the regression line of y on x is you treat the x values as accurate and you try to minimize you get the least squares between x and y. Okay? So you just kind of estimate the lines when you're doing the exam, I suppose. So remember, you always take the x value as accurate for regression line of y on x and vice versa. So it minimizes the sum of squares with residuals in the vertical direction di, so the sum of di square. Then the reverse is true for the regression line of x on y. Okay? So this hence describe the difference is a bit, I don't know how to say lah. I don't know if it has come out for A-levels before, don't remember. But I think it is still a good thing to take note of. But I think that the effect might be better if we show all the differences. So for example, y on x, you show this difference, this difference, you do the same with this. Then you kind of like show that it's the sum of all these d1, d2, d3, d4, d5, d6. Then you do the same for the horizontal regression. Yeah. Okay, this is the more familiar one to us, right? 10b. Okay, so if you draw the scatter diagram, this is a T and this is D. Okay, so I think the trend is like curve shaped. So you label the max and mean. The max is 80, the mean is 22. This is 50 and this is 100. So you do this. 55 will be somewhere here. 45 is somewhere here. 35 is somewhere here. 25 is somewhere here. And 22 is here. Okay, so it's kind of a curvy linear trend. Of course, if you have the GC, you can get the more accurate one. So this one is which is the most appropriate model. If you go and work it out, so we will need something there's two conditions. It needs to be decreasing and concave upwards. So pick a model that satisfies this condition, which will actually be the second model. The first model is a linear one, so it doesn't work. The second model, because A is less than 0, it will actually be concave downwards. But the second model is decreasing and concave upwards. So it meets the condition. So therefore the model 2 is good. Okay, or is appropriate. Okay, regression line, you can use your GC to find. I hope you know how to use your GC to find the equation of a regression line. But take note that the question says that you need to give the regression line to 3 decimal places. So I got t equals to 5,767.446 1 over d minus 37.619. As the question says 3dp, so make sure you do that. The product moment correlation coefficient R is 0.995. Yeah. Again, I believe many of you will know how to do this by yourself using the GC. 10b part 3. Estimate the duration when it's 150 feet below sea level. Okay. So once again, you just plug in d equals to 150 and see what happens to t. You'll get t equals to 0.830. And then at this point, you will kind of realize that there's a problem, right? So is it reliable? Not reliable. D equals 150 is outside the data range. Also, 0.830 is like very low. That's a very short amount of time in minutes. Yeah, not very safe to be down there apparently. Okay, so basically this is extrapolation now, right? So it's not reliable. Okay, a distance of 1 meter is 3.28 feet. Rewrite the equation from part 2. Okay, so by the way, this did come out for A levels before, so don't be surprised. We simply replace D by 3.28D. Or rather, replace 1 over D by 1 over 3.28D. This came out for my prelims as well, actually. I'm from ACJC, I took the 2022 prelims. It came out for my prelims also. I think the CNR was about cheese consumption or price, something like that. Okay. And you will get, I can rewrite it as 3SF because it's a standard. They never say what accuracy to leave it, so I shall leave it in the standard D. Oh, it's a capital D. So replace D by 1 over 3.28D. Okay. So 1760 over big D minus 37.6. And this is in 3SF. A new data pair is added to the set given in table A. The product moment correlation coefficient does not change. Find the possible DT. For this, we just do, we know that the point x bar y bar must lie on the regression line, right? Okay. Or rather, I should say d bar and t bar. Okay, so bar, so this is actually 1 over d bar and t bar. Lies on the regression line. So you get d bar equals to 1 over. So you can of course find 1 over d bar using your GC. You get 0.0140939,153. So therefore d bar, oh, this is 1 over d bar. D bar is 71.0, 3SF. And the corresponding t bar you can find also. Actually, I should write d prime t prime, right? So d prime t prime. T prime, once again, you can find the mean. You can find the value of t that corresponds to this value of d using the regression line. And if you do that, you'll get 43.7. Okay? Yeah. Finally, we come to the normal distribution. Okay. This one is slightly interesting. 11, the first part. Show that mu1 plus mu2 is 325. So read the question very carefully. The vending machine has 2 types of coffee, black and white, and it dispenses normal distribution mean mu1, standard deviation 11.83 ml. The white coffee first puts out the black coffee, normally distributed mean mu2. The standard deviation is 11.83, exactly the same. And now we are given this, show that mu1 plus mu2 is 325. Okay, so what we do is we sketch the distribution curves of x bar and y bar. Of x and y, sorry. Okay, so this is a mu1 and this is mu2. The probability that x is less than 175, so we don't know which one is more. Let's say that let's first assume that the tail is over here. Okay, then this one is 150. So therefore, I want this value and this value to be equal. So symmetry. By symmetry, so therefore mu1 plus mu2 equals to 175 plus 150 equals to 325. Okay. Now assume that mu1 is 180, so in fact it is going to be to the right of 175. Okay. Find the probability the total volume of 2 randomly chosen cups of black coffee exceeds twice the volume of randomly chosen cup of white coffee by less than 15 ml. So I'm going to use the variable d for the difference. But first, let me define what that is. So, because 2 randomly chosen cups of black coffee, that is 2 independent observations of x, so x1 plus x2, then minus 2 times of 1 observation of y and 1 observation of m. So y plus m. Okay? So therefore, d follows the normal distribution. The means will add up to, you'll get 2 times 180 minus 2 times 145 plus 30. And the variance is 2 times 11.83 square, because given standard deviation. Then when you do minus random variables, you actually plus the variance, and you square 2. So you get 2 square times 11.83 square. And actually, you need to plus m also. So you plus the 5.92 square, which is the standard deviation. And this will be your variance. So D actually follows the normal distribution with mean 2.85. No, wait, I'm reading the wrong part. The mean is here is 0, sorry. 2.85 is later. 0 and 979.879. So we need the difference to be more than 15. So the probability that, okay, here's the important part. 979.879, if you square root this, you will get something that's like more than 31. So there's a very good chance that it will actually be less. But we want it to exceed. So we must actually put a 0 here. Okay? And we need to see that the exceeding is less than 15. So 0 less than D less than 15. Okay? Then we use your GC, you will get 0.184. Okay? And what is the assumption? Okay, this one is also quite standard. Assume that the masses of all the cups of coffee and milk are independent. Okay, I should say black coffee. Yeah, they are all independent. That is the assumption here. Okay. 11 part 2, black coffee is sold at $4 per cup, while the coffee is $5 per cup. Okay, black coffee is 1 cent per ml, and the cost of ingredients for the milk is 2 cents per ml. 100 is sold per day, N is black coffee, the rest is white coffee. Okay, so let's define some variables. I don't like using B. The marking scheme actually use B for a black coffee, but I don't like that because B can also mean binomial distribution. So I typically don't define a random variable as B. Let's see, how can I do this? Well, I don't have any other good variables. Let R be the profit from milk. Oh no, coffee. Black coffee. S be the profit from milk. Oh wait, no, from white coffee, I should say. Not milk, because you're not selling any milk. From white coffee. And I will tell you how we will solve this later. Okay? So, We have R following the normal distribution. Now it is $4 per cup. Now you need to minus 1.8 because that is the cost price of one black coffee. And then what is the variance? The variance is 0.01 squared because it's a $0.01. We square that times the standard deviation square. Okay. And this is the normal distribution with mean 2.2 and variance is 0.013999489. Okay. S follows the normal distribution with mean 5 minus, once again, you need to account for the black coffee cost, which is 1.45. It costs 2 cents per ml of milk and it's 35 ml, so it's 0.7. The variance here will be 0.01 squared times, okay. And then same thing, you need the 11.83 square. And then you need to add the variance of the milk, 0.02 square times 5.92 square. Okay, which is the normal distribution with mean of 2.85, 0.02801345. And clearly you can see that the white coffee makes more profit than the black coffee. So define T be the total profit. Let T be the total profit. Do not confuse this T with T distribution, although I don't think you will because it's not in H2 anymore. So T is actually n independent observations of R, not n times of R, those are two different things. R1 plus R2 plus dot 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 plus Rn plus S1 plus S2 plus dot 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 plus S100 minus n. Yeah. And we can work out this. This is T follows the distribution. Okay, be very careful here. So you take 100 times the mean of 100 times 2.2 minus 100 minus, sorry, n times of 2.2 minus 100 minus n times of 2.85. 2.85. So you get 285. Then the difference is 0.65. So you get 0.65n. And the variance you can do it in the same way. It's a very lengthy calculation. But essentially what you're going to get is 2.801345. Okay, you need to account for the difference in n. So even though it's variance, you are actually doing a minus here because of the fact that you are doing 100 minus n independent observations for the variance of the white coffee. You get 0.0141856n. Okay, yeah. So we now need to find the probability of total profit earned per day exceeding 230 is at least 0.8. So we now using GC. Using GC, we have we draw the table, of course. We have N, P, T is greater than 230. Okay, so we get the value of N we need is 82 if you use your GC. And I'll draw the table here. 81, 82, 83. So the probability table is 0.966. So you'll see that it's a very high probability at first, but the probability quickly decreases. This one is 0.907, and this one is 0.794. It's a very quickly decreasing number. Yeah, therefore, n equals to 82. Largest n. Okay, largest n is 82. Boost the sales from the coffee vending machine. If it dispenses fall below a certain level, receives the drink free of charge. B% select black coffee, receive the drink free of charge. 3 are chosen at random. State in terms of P the probability that exactly one of the 3 customers receive the drink free of charge. So you can define a binomial variable if you want. I think Hua Chong did that, but it's not necessary. It's actually just 3 choose 1. You choose one of them to be free. And then the probability that you get it is P over 100, right? Because P%. So P over 100. Then you do 1 minus P over 100 of the 2 customers that didn't get the free cup, is that. So this simplifies to 3 over 100, 3P over 100, 1 minus P over 100 square. I think this is sufficient for this part. I'll name this part 11 part 3. Is it 11 or 12 again? Yeah, it's 11. Okay, so 11 part 3. That's all. And then finally, the last part. Given that the probability of exactly one of the 3 customers receiving the drink free of charge is at most 0.1, find the range of values of P. So we are solving 3P over 100, 1 minus P over 100, square less than 0.1. At most 0.1, less than or equals to. And here's a tip for you guys. Instead of entering P over 100, enter X first into your GC. Then you take whatever values are there, you multiply by 100. That will be an easier way for you to get it from the Z standard setting. Because the values will just be between 0 and 1, so you can easily find the x-intercepts. So by GC, if you do it, you will get 0 is less than or equals to P, less than or equals to 3.59, or 79.5 less than or equals to P less than or equals to 100. Yeah. The reason why it actually works even though the P is close to 100 means that it's starting to be more likely that more likely that 2 or even 3 customers receive a drink free of charge, right? And ideally, of course, if the latter part is happening, obviously you need to fix your coffee machine lah. Yeah. Okay. So that's it for Hua Chong. I think it was a pretty good paper. Oh god. Okay. All the best for everyone taking the A levels. GP is tomorrow, and H2 Math Paper 1 is pure math only. It will be on Tuesday. And the paper 2 with pure math plus stats, like this paper, will be on Friday. So before then, I will get the stats up for ACJC 2021 and Diamond High 2022. Yeah. All the best for your A levels, everyone. I'm the same boat as you guys. Yeah. Alright, and thanks for watching. I'll see you guys next time.